Welcome to Built, Wired, and Secured, the podcast where we explore how modern buildings are designed, connected, and protected in the real world. I'm Alex Morgan, and in today's episode, we're diving into the quiet dominoes, preventing cross-system cascades in commercial buildings, why it matters, building operations, and resilience planning. Michael, thanks for being here.
Thanks, Alex. Glad to be here and talk about something that quietly breaks buildings more often than people expect.
Picture this. It's a normal Tuesday morning. A motion sensor in a tenant suite starts triggering false occupancy signals. The building automation system interprets that as an over-occupied zone and ramps up ventilation. The extra load taxes a distribution panel that was already near capacity, which trips an upstream breaker and knocks out network equipment in the comms room. Tenants lose badge access, the elevators go to independent recall, and the receptionist has to let people in manually. One small sensor glitch, and suddenly operations are in crisis. That's the kind of domino effect we're unpacking today.
I've seen versions of that exact chain. What breaks if this goes down? Tenants feel it first. Lost access, uncomfortable spaces, meetings delayed. But the operational costs and reputational damage stack up fast. From an operational standpoint, Cascades show two recurring problems: hidden dependencies and unclear ownership.
Let's start with causes. What are the common hidden dependencies and single points of failure you see across power, networking, and controls that let a small fault escalate into a building-wide outage?
Three big categories. First, shared physical infrastructure, a single comms room, a single UPS or distribution panel serving multiple critical systems. Second, logical coupling, separate systems that rely on the same network or authentication service. Third, undocumented operational workarounds that accumulate over time. Any one of those is manageable. Combined, they create brittle interactions.
Can you give an example of logical coupling that surprises people?
Sure. One common surprise: access control systems and building automation, both tied to the same authentication service or network VLAN. When that off service or VLAN has problems, you don't just lose badge reads, you can also lose HVAC scheduling or emergency alerts. People assume systems are independent because they're different vendors or different panels, but they're actually using the same backplane.
That leads naturally into our second section, trade-offs. Building in redundancy often seems like the cure, but it can introduce complexity. How do teams balance redundancy against the operational cost of managing more systems?
Redundancy isn't one size fits all. The trade-off is between risk reduction and the operational burden of maintaining additional paths. A second UPS or a parallel network segment can reduce single points of failure, but now you have double the assets to test and two configurations to keep in sync. That's fine until it fails. And when it does, the recovery can be slower because teams sacrificed simplicity for theoretical resilience without operationalizing it.
What about manual workarounds? I hear a lot about temporary fixes that become permanent. Is that a major contributor to Cascades?
Absolutely. Manual patches, like routing access control through a separate guest VLAN because the main VLAN was acting up, create hidden dependency shifts. They often bypass monitoring, skip documentation, and get forgotten. The next time something fails, nobody knows the real topology. That's when repairs take longer and fixes have unintended side effects.
Let's move to implications and examples. You mentioned earlier you've handled a few incidents. Can you walk us through an anonymized lesson where a small issue became a major disruption and how the team recovered?
A recent case: a contractor replaced a lighting control panel and failed to route its management traffic away from the tenant VLAN. A firmware update caused excessive broadcast traffic, which saturated the switch stack. The switch stack powered core network services into a degraded state. Phone systems and badge readers lost connectivity. Tenants were locked out of floors, and meetings were delayed. The team recovered by isolating the broadcast source, rolling back the firmware, and manually restoring key network paths. But the real learning came after: mapping every device to a VLAN ownership, instituting a change control checklist, and adding monitoring that would have flagged the broadcast storm before it cascaded.
That mirrors what we hear often. Recovery is possible, but expensive and reputation damaging. So what does an operational playbook look like? Short, practical steps teams can adopt this week to start containing these dominoes.
Start with 3 actions. 1. Dependency mapping. Document what systems run on which panels, VLANs, and services. Even a simple spreadsheet beats assumptions. 2. Ownership and handoffs. Assign clear owners for each dependency and formalize change control, so no device gets moved without notice. 3. Tabletop exercises. Run short scenarios that simulate a small failure and walk through the operational steps to contain it. Those exercises reveal brittle interfaces and produce the real checklist you'll use in a crisis.
Any low-effort wins that facilities or IT teams can implement with limited budget?
Yes, labeling and documentation are the highest ROI. Label power feeds, network jacks, and patch panels clearly. Add simple monitoring for broadcast storms and power anomalies. Define a critical path list, which 5 systems must remain online for tenant operations, and what manual workarounds exist if they fail. Those steps reduce mean time to recovery dramatically without large capital spend.
Okay, to wrap, let's run through 3 key takeaways for listeners to act on after this episode.
First, map dependencies. Know which systems share power, network, or auth services. Second, assign ownership. Every dependency needs a clear owner and a documented change process. Third, test deliberately. Short tabletop exercises and simple monitoring catch brittle interactions before they cascade.
If you're responsible for a building, audit the critical path systems this week. Label infrastructure, run 1 tabletop with facilities and IT in the same room, and add 1 monitoring rule that will alert you to abnormal traffic or power behavior. For more resources and episode notes, visit our show page at the Built, Wired, and Secured site.
Small steps make a big difference. If you can stop 1 cascade before it starts, you've saved hours of downtime and a lot of frustration for tenants and staff.
That wraps up today's episode of Built, Wired, and Secured. We covered how small failures turn into cascading outages, and we gave you concrete, vendor-neutral ways to map dependencies, define ownership, and test your way to resilience. Thanks for spending time with us. Until next time, make sure the systems you're responsible for are built to last, wired with intention, and secured for the real world.